vast experience in the Middle East region in inspection, assessment, analysis, and repairs of assets for both reactive and preventative maintenance of civil structures. Murthy has solved many structural problems for oil and gas, metro ports, both above water and underwater, airports, bridges, and tunnels. We also have today a guest speaker who will be talking about the proactive maintenance approach. The speaker is Nick White. Nick is a senior associate director and the head of Owners Association Services at Astico Property Management. Murthy, the floor is yours.
Thank you, Karam. This is the Murthy that Karam has just introduced. And before I jump into the subject, a short introduction to Simco Technologies. I'm the Regional Director for Simco Technologies, Middle East. The Simco Technologies is headquartered in Quebec. We are 30 years old. Our specialties are restoration and durability engineering. We have been present in the Middle East from the year 2004. As you can see in the bottom, our first job was for the Burj Khalifa, which is an iconic structure in the world, not just in the UAE. We have our structural engineering offices in Montreal, and we are here not only in UAE, also in KSA, Saudi Arabia as well. Now, the subject that I'm going to be discussing today is underground parking structures and its service life. Sorry about the glitch. There is nothing you have. There are many. Sorry. I'll be talking about underground parking structures and its service life, some serious structural problems, safety issues and their causes, an inspection program and proactive and protective maintenance, impact of repair timings on overall service life and repair costs. Underground parking structure, there are many kinds of underground structures. You have water tanks, tunnels, and you also have parking structures. There is nothing wrong in having an underground parking structure as long as it is protected against the groundwater. Many times you see the groundwater seems to be the villain. I'll explain to you why. Why the parking structures are important. The parking structures have massive commercial value. How? Let's take a building. A high-rise building, let's say 30 floors, and it has got about an apartment, and you pay a rent of about 300,000 per year per apartment, and they give you 2 car parking spaces. And these 2 car parking spaces, if you are not able to provide, each car parking space is about 6 into 2, 12 square meters. Let's say 10 plus 10, 20 square meters. If you are not able to provide that, which is 2 car parking spaces about 20 square meter each, for the following reasons, you can't fill the office space. There goes your 300,000 per year. I have seen this happening many times. I've even been invited to other Emirates, not other Emirates, other countries as well, Kuwait for example, and they built a beautiful structure by the royal family, and they couldn't rent out the entire basement floor, and by which they were losing about $1 million per year. So it's a big issue. So it has got a commercial impact. Is that the only one? Let's say you take the case of a mall. You have a mall and the car park becomes unusable because it has got a groundwater leakage problem, and you have that many less customers. In all cases, the car park structure plays a very critical role in the commercialization of any real estate venture. Now, having said that, is that all? let's take the life cycle of the structure. Now, what is a design life? A design life, it is the period of use as intended by the designer. Why I say this is because even though the code EN 1990, it gives you an indicative design life. It doesn't say that you have to have it. It doesn't give you, it's not a codal instruction. It's an indicative design life for various types of structures. Let us say you are talking about a car park structure. Car park structure is mainly, let's say, for multi-story buildings, commercial structures. So the code says, what is the indicative design working life? It's 50 years. So some of the audience here who are in the design of the buildings would know that you are building or designing a structure to have a durable life of 50 years. But there is no legally agreed term for design life. You cannot say that, okay, I'm designing it because of the code, and that's why you must have 50 years or 75 years or 100 years. For example, the structures such as a bridge nowadays are designed for 100 years. By the way, all the structures which are being constructed today by RTA here, the bridges, metro, everything, the design life is 100 years. But let's talk about the 50 years. The design service life can be affected by the environmental conditions. That is why it doesn't have a legal agreed term. It's only defined by the contract. It's affected by moisture, by humidity, by rain, wind, temperature fluctuations, which is the highest here. It goes from 6 degrees to 50 degrees. Pollution and solar radiation. Because you have so many variables, they don't define it, but it's only defined by the contract. Now, when you build a structure, 50 years of service life in your mind, this is what you imagine, this is what you want to have. But what you get within the first 10 years of your construction is you have the leaks. You have massive leaks, spalls, efflorescence. These are the common sights in many of the underground parking lots that one may see. So what? So what is the first reaction of the owner? The first reaction of the owner is, okay, I see a leak. I call the main contractor who built this because I still have a 10 years warranty. And the main contractor has got a warranty with his waterproofing contractor. He calls a waterproofing contractor. He comes and he does some injection interventions. The water stops for a while, but appears in another place, or sometimes it even appears in the same place. So on and so forth. It drags on for years. Okay, I have a spall. I call a contractor. Again, I call the contractor. He sends 2 masons. He patches it up. It appears again in another place. 2 more masons. So on, so forth. Okay. The efflorescence. Its paint is peeling off. It's an unsightly. So what do? I call my maintenance team. This time I don't even call the contractor. I call my maintenance team. They come here, scratch it off, they paint it, and this comes again, and then I paint it again. So on, so forth again. People, I'm not really joking about this. I'll tell you why. Look at this picture. Now, this is about 3.5 years old. I was called by the authorities. I cannot name the authorities. I was called by the authorities to inspect a building which has got this accident. There was an old lady, the mother of the house, was sleeping on the side where you see the block of concrete lying on the bed. You could see the pillow there. Fortunately for her, she just got up to go to the bathroom, and then she came back and sat down on the other side of the bed. For the privacy reason, I cut off that picture. and then the concrete falls down. Imagine what would have happened a couple of minutes before she had left. He could see her slippers and he could see that she's sitting on the other side of the bed, completely shocked. Now, when I was called to this building, I go there and I said, okay, all right, guys, show me your structure. This is what they showed me. This was the ceiling where the concrete fell down. I was so astonished because this was 1 week after this accident has happened. And the tenant has said, yeah, the owner has sent a couple of masons. They came here, they patched it up, painted it and put the lights back. Here how it looks. Then I told him, look, it's going to come down in another couple of months again. So this is the attitude. If this could be the attitude when it comes to such a safety issue, you could imagine that when it is not really affecting somebody in a car park structure, it gets delayed and delayed and delayed. How is your service life compromised? You know, we talked about the service life. We talked about 10 years. We say, okay, why do I have this problem within this 10 years? Let's take at the groundwater in UAE, the quality of the groundwater in UAE. The salinity of the seawater in the Gulf is 35,000 ppm. Now, the groundwater in UAE, according to the groundwater atlas, is 3 times the salinity of the Arabian Sea. You could imagine how saline the groundwater is. It's even worse than the seawater. That being the case, it's getting saltier every day. It's a truth. You see this map. This is the groundwater salinity map. The one that you see in the dark red is the 3 times the salinity of the sea. Then as you go gradually inland, the salinity decreases. Where do you have the fresh water? In this entire map, that's all the place you have this fresh water. The rest are all saline water with various concentrations. So this being the case, you build a structure in this country under the ground and you have the salt water around with varying degrees of salinity. So what happens then? When this water of such salinity leaks through, a couple of things happen. One, the chlorides in the water contaminates the concrete and breaks down the passive layer around the steel reinforcement, which causes a corrosion. But wait, what you see is that, all right, I don't see the water. I see some peeling of paint. You scratch the paint. You see a salt deposit. Where does it come from? Let me explain. Now, concrete is a semi-permeable medium. It has got pores and pores and pores. You've got gel pores, air pores, capillary pores, sedimentary pores, micro cracks, aggregate grains. All these pores are interconnected. When these pores are interconnected, when water is going to come through, then it travels through these pores and it comes to the other side of the concrete, from one side to other side. One side you have a highly saline water and this travels through your concrete. And that is where your salt deposits are going to happen, as I am going to show you now in a minute. Now the killer, what is the killer? Is that this is your basement. You have the groundwater. The waterproofing fails. That's the first problem. When the waterproofing fails, the groundwater starts penetrating into the concrete matrix. It comes out of the concrete on the other side and vaporizes. Right? When it vaporizes, the chloride or the salt, in simple terms, that is bringing along, is deposited. It builds up. When it builds up, this is the one which is peeling off your paint. Then you scratch the paint, you find kind of a salty whitish thing underneath the paint. This is what happens. Now, what helps this evaporation? Now, temperature, relative humidity, and the airflow. When this evaporation happens, it draws out more water and the process continues. You see, when you have a fluctuation in temperature, when you have the relative humidity which is lower, and then it sucks in this moisture and it draws out more water, and the process continues, and when the vapor evaporates at the surface, it leaves a sodium chloride on the surface. Now this sodium chloride, what does it do? You are going to see the next slide, which is a very common slide you might have seen before if the audiences are the same like us. You see, you have this reinforcement bar which has slight rust around, and this rust starts building up, expands, cracks, delamination, spot. And that is when normally you notice. You go there and see, okay, all right, hey, I have a spall. That is when you start looking at it. You will connect this slide to one of the last slides I'm going to show you. Now, we said this water, highly saline water, it goes through the concrete, comes up. Is that the only thing that happens? In this country, the groundwater table goes up for varied reasons. Landscaping and irrigating around these beautiful buildings. When the designer designs these buildings, the groundwater table was at one level. But by the time the building is finished, beautiful landscaping done around, then you start irrigating this, the groundwater goes up. When the groundwater goes up, the problem happens, which I will come to that later. Then you also have a canal. It's a unique thing here in Dubai. You said you have a canal that wasn't there before. Now, because this canal is running through a cluster of high-rise buildings with many basements, this has brought in its own problem, as you can see in this building. So what are the consequences? Uplift pressure on the raft, cracks, water starts flowing out in torrents, erosion of soil underneath an unequal settlement. These are the pictures that you see from this country. I'm not showing anything out of this country. This is real. This is what's happening. And all the pictures that I'm showing you, I won't be able to name the structures, but I can tell you we addressed all the problems. Now, how? Let's imagine for a moment. You have a 30-story building, and this 30-story building has got, let's say, 2 basements, and the whole load of all the 30 stories are coming to the last basement. If I take a ballpark figure, maybe each column could be transmitting something like 30,000 kilonewtons. And when such a load, these are the kind of columns you are going to have. That's what I have. We are living in a dangerous situation, like you have massive buildings standing on top and you have everything compromised at the bottom, whether it is a retaining wall, whether these are the columns which are carrying the loads, you do have a problem. So what do? Let's have an inspection program. Get somebody who is experienced. That's an important thing. Check the track record of the company that you are inviting to do the inspection. You may think you don't need a genius to tell you that the waterproofing has failed. Correct? The waterproofing has failed. That's why you have the water coming into the building. But you need somebody to tell you why it has failed. Is it the system that has been wrongly specified? Is it the material in the system that has malfunctioned? Or is it the workmanship that is bad? Or the design itself? So you need somebody to tell you why. Once you know why, which is the root cause of the problem, then the solution becomes easier. This is where you need somebody with experience. Somebody who tells you why it had happened, how this could be fixed, and how much would it cost. We offer you a free inspection of your basement without any obligations. And we will provide you a written report at the end of this investigation or free inspection. As I said, without obligation. You may call us again or you may not call us again, doesn't matter. At least you will have the satisfaction you call somebody who knows what he's talking about. What are the kind of investigation that one can do in a basement? Visual. Then we also do the acoustic impact testing, rebound hammer testing, GPR survey, ultrasonic pulse velocity testing, half cell potential, LPR. This linear polarization resistance, this is something which many people do not do. This gives you the rate of corrosion of the reinforcement. Then we also take the field sampling and breakouts. There are some high-end equipment that we use nowadays to find the voids inside the concrete without breaking it. One is a very common one, ultrasonic pulse velocity, that most of you are familiar with. But this is a new one, which is ultrasonic tomography, which can actually find out the voids deep down the concrete. For example, our latest project that we have done for the government is where we have investigated a tunnel which is about more than 40 years old, and we checked the integrity of the walls by checking whether it has got any voids inside or not. It came out to be very, very successful. We also do semi-destructive testing. You see the core that we have taken. We put it in a scan. By digitizing this core, we can slice the core without physically slicing the core. We can digitally slice the core, like an MRI. I believe that some of you or many of you may know what an MRI is. You go there, your heart is scanned, and then they slice it digitally and then try to find out what's wrong in it. That's exactly what we as Simco, we are able to do. We can take the core, we can analyze the core digitally without actually cutting the core or slicing the core. We also do the half cell potential, which is a very common one done by many labs. That what we do is that we take the readings, superimpose it on your structure, and tell you exactly where you have the probability of corrosion. The one in the red are danger zones. Mostly our experience shows that your problem comes mostly nearer to the expansion joint which are leaking, or construction joints which are leaking again. These are the vulnerable area that we have found out. I will connect this slide to another slide as we go down later. Proactive and preventive maintenance. What kind of proactive and preventive maintenance that one can take? Get an inspection done by a professional company. What happens if not? I'm going to give you two real life examples. Now, a consultant has done a field testing, used a laboratory to get some cores, do some tests, and this is what he has produced. I want to highlight here, this is a threshold value that he has used in his report in order to show to the client that all the chloride levels are below that threshold at the depth of 50 centimeters. I don't know whether you are able to see my mouse. You can see this is the depth of the reinforcement. This is where the reinforcement is. According to the threshold that he's showing, all the chloride levels are below the threshold level. So reinforcement is not in danger of corrosion according to him. Is that the right one? No. Why it is not the right one? I will show you in a minute. Because this is the threshold that he should be using. What he has done, either by ignorance or by whatever, he has used the wrong codal values. You can see that the one that he is using as a threshold is for concrete without reinforcement. And this is a rough slab. This report pertains to the rough slab, which is a reinforced concrete slab, and he is using a threshold value which is related to the concrete without reinforcement. And what happens? If you can see the second arrow, at the 50 centimeters depth of the cover, you can see all the chloride levels are above the limits. The structure is in danger of getting corroded, or it has corrosion has already started. Corrosion has already been initiated. Let's take another example. I'll show another one. Now, in this one, this is a structure which is a couple of years under construction. Now, a consultant has been employed, and what he has said is that the external reinforcement, he says in his report, this external reinforcement is not in danger of corrosion at all, because he says it is permanently immersed in the groundwater on the concrete surface, which is true. This surface is 100% saturated because of the groundwater. Is it the right one? No, it is not. Why? Because here at the surface of the concrete, it is 100% saturated. But at the surface of the reinforcement, which is probably 75 mm behind, it is not. There is a certain amount of less than 100% saturated surface. It's not the 100% saturated surface. Because of that, there is a certain amount of oxygen present. All of you know that oxygen is an important component for the corrosion to happen. The consultant says because of lack of oxygen, the corrosion will never happen here if you have its design life. But that is not the case, because there is some oxygen which is present. Maybe it's not going to happen in 5 years. Maybe it's not going to happen in 10 years, 15 years, 20 years. But this structure is designed for 50 years. Will this last for 50 years? That's a question mark. Now, what happens then? As I told you previously, or as I've shown you previously, that there is a chloride built up on the interior surface, which is efflorescence. Now, this efflorescence has got a higher quantity of chlorides at the surface. Now, these chlorides will start traveling inside the concrete, because the chloride concentration will always try to find its equilibrium. When that happens, the corrosion will definitely happen, not only on the inner reinforcement, also in the outer reinforcement. So the consultant said, your structure is not in danger of performing in less than design life of 50 years, which is not the case. His written report, he says, the service life has been compromised. The service life is shorter than the design life. It's a court case now. But how do you find out? There are ways of doing it. Now, next, get a company of repute to carry out the mitigation. Okay, all right, now you identified your problem. Your problem has to be mitigated, addressed. Many times I see the people do not go to reputed repair contractors. They go to main contractors. Main contractor have lots of strengths. They build some beautiful buildings. But this is a niche area. This niche area requires a certain skill, that certain skill set that's available only with reputed repair contractors. What happens if you don't go to them? You go for repairs to the repairs. You do the injection, water comes again. You go there, patch it up. Look at the center figure that you see here. This was a patched up repair, and you could see that it comes out again. And you lose a valuable time in between, because the propagation of corrosion is not linear. Impact of the repair timings. When do you have to do the repair? That's a big question, isn't it? What is the cycle? The defects are noticed. A consultant investigates, report submitted, goes for approval of budget, goes out for tender, goes out for award, and time taken, anything between 1 to 3 years. Now what happens between this 1 to 3 years? The propagation of corrosion or the problem has increased between 25 to 100%. As I said, it's not linear. For example, when do you go when you see the problem? Mainly the people go there in this area when they see visible cracking and spalling. After that, the curve doesn't go in a linear way, it goes very steep. That was why from here when you do the investigation and do the mitigation should be as quick as possible. Ideally, you should do it much before. That is why an inspection, if you have an inspection today, probably you will find out whether you are here or here or here. And I will connect this to the cost that you are going to have. Because the incremental curve is not linear, as I said in my previous slide. Why not make a provision during the investigation stage? You can ask, okay, we have done that. We say, okay, all right, we are investigating it. Let's say we see about 100 square meters of repair that is to be done now. Why don't you make a provision? Yeah, I can make a provision. But how much is a provision that I shall make? Shall I make 25%? Shall I make 100%? Shall I make 50%? Because this is very, very subjective. Because it all depends on many factors, such as exposure, your humidity, your temperature, and it varies. When it varies, then you have the curve takes a different tangent. So whatever provision you make may be right, maybe not right, because it's only a guess. But is there a way that you can make it more accurately? Yes, there is a way. We can predict it very accurately. There is something what is called Stadium, which is a software and a protocol by Simco Technologies. We can model the deterioration with a good amount of accuracy. But that calls for this another subject that itself is another webinar. So we will cover it probably later. But all I want to say is there is a way of accurately predicting it. The overall service life and repair cost. Let's recall. We said 50 years of design service life. But the problems are noticed even before the 10 years. The big question, how can I get back my 50 years and beyond? A good durability and repair consultant shall be able to help you. We devise various options of repair. All these options can even be modeled by Stadium if need to be, to find out what shall be the remaining life for each kind of repair. For example, you say that, okay, I notice these problems in 10 years. I want to have my 50 years. we can provide you a calculation and tell you, if you want to have your 50 years, you can do these mitigations. You can do these kind of repairs. This will cost you so much, and you can do it at this time, and you will still have your 50 years. And you say, okay, all right, I don't want to spend that money. Probably you're asking me to spend about a couple of millions, which I don't want to spend, because there are owners who have come to me and told me, look, we don't want to spend this money because we are going to sell this structure in a year. So show me something that I have to maintain it only for a year. It doesn't look good, but this is a reality. There is a big shopping mall, which they called me and they said, hey, we have a problem of water coming at the basement, and it's like the efflorescence problem that I was showing you, and the owner had a problem of selling this to the buyer because the buyer was asking him some uncomfortable questions. So what we said, okay. So he called me and he said, hey, can you stop it? I said, we can. But I told him something very quickly. I told him, if you adopt this, if you are able to provide a little bit larger surface area at the point of exit of this moisture may not spread that quickly to the upper portions. You can contain it at the bottom portion. What would it cost him? Probably 10% of what it would be if you are going to do the full repair. He said, I would take that option. Well, we lost a good job, but he got what he wanted. But all these things can be modeled by Stadium, which I will show you. The picture looks simplistic. It is an actual output from the Stadium. Now it shows the curve that you see here is the threshold value is 0.05. If the contamination exceeds the threshold value here, the life is shortened. So what shall be the objective? The objective is that to keep the contaminants below the threshold value. In order to do that, we have modeled 4 different options. One option was, if you don't do any repair, what will be the service life of your structure? If you do, you see, at this, say at the year 30, maybe we are talking about year 10 now, because most of the buildings here, this is from North America. Most of the buildings here, in 10 years you are here, the curve is here. If you do something here with only a limited amount that you want to spend, your service life is extended to yes. But if you go and remove a certain quantity of contaminated concrete and do an overlay, then your service life, that you are bringing the contaminant levels to well below this level, your service life extended by, let's say, X2. But if you are going to do a full repair with a complete patch repair, removing the contaminated concrete both above the reinforcement and below the reinforcement, then your contaminant level comes down here. You have a very long service life. This can be modeled even before you start touching your site. But as I said, this is a choice that a building owner can have. Repair cost. A good consultant always proposes an optimum cost. It should never be an overkill. What I mean by optimum? Let's take a case. The investigation report shows that the chloride contamination and the reinforcement corrosion have reached critical stages of safety. Mostly it happens in basements nearer to the leaking expansion joints, construction joints, cracks, etc. This can be found out by the half cell potential that I have shown you in my previous slides. If you superimpose it, you will exactly see it's more nearer to the joints. Now, this being the case, what shall be the mitigation? A good consultant will say, okay, because majority of the areas the probability of corrosion is high but not yet corroded. We have two ways of approaching it. One, propose a cathodic protection solution to 100% of the area, make it absolutely sure that the design service life is met. Yes, you can do that. It's a good solution. But is it an optimal solution? Maybe not. Why? Because you can propose, hey, I'm going to provide the CP only in the critical areas and provide monitors in the rest of the areas and do the CP in those areas only if and when the situation warrants. The savings could be anywhere between 40 to 50%. So this is what a good consultant shall be able to provide you. Now I'm coming to the last, this is the last but one slide. I'm coming to the last slide. This is the law of 5 by de Sitter. If maintenance is not performed, then repairs equaling 5 times the maintenance cost are required. If you don't do the maintenance, you have to spend 5 times when you are going to do the repair. If these repairs are not carried out, then renewal expenses can reach 5 times the repair cost. Therefore, postponing the maintenance compounds the amount of deferred maintenance. Who is saying this? W.R. de Sitter. Now let us look at this. This is the famous de Sitter's law of 5s. $1 spent on monitoring saves you $5 spent on preventive maintenance before corrosion initiation. This saves $25 on repair and maintenance after localized corrosion initiation. And it saves $125 spent on repair and replacement after generalized corrosion. As I told you, it's never a linear. You can see how steeply it goes up. So the timing of the repair is very important because that's going to save you a lot of money. I reiterate once again, we are offering you a free inspection of your basement without any obligation. Thank you very much. I can be contacted. My contact details are here. We also have Mr. Redwan Hamid in Saudi Arabia, and he can also be contacted in Saudi Arabia, or any audience from Saudi Arabia. You are welcome to contact Redwan. And thank you very much. And the next one is going to be my co-speaker, Nick White, and he's going to take the stage. He can give you some insights from the owner's point of view.
Thanks, Mordi. I'll just share my screen with everyone. Okay, there we go. Thanks, Mordi. Very interesting. It always brings me to a point of saying, you always don't know what you don't know, I think is the main thing. And I think I'm just going to do some commentary just briefly because we haven't got long left, but to align how I would approach the same subject as a manager in a property, of a property and different clients. And I think that's the difficulty of our job is that actual fact. So my screen is not, there we go. And this is a precursor to Wednesdays as well, but we're only going to go through part A. Because in our business, we act for a client. That can be an individual property owner or multiple property owners, as in my department, which is a jointly owned property division. Now, that in itself brings on an amount of responsibility and liability to approach the repair and maintenance of buildings on behalf of other people. So it's not what I want personally to do. It's it is best for all. The best timing, the best value, the service life all comes into play. Although we are then an independent party able to make the optimum decision for the lifespan of that building. So our main concern is with service charges and the costs to either a landlord client or to multiple owners, and bringing them best value and making sure that those costs are not going to be prohibitive at any point in time, that we can approach it so that we're able to either delay or put in place certain works to level out the impact of costs to them over the lifespan of the number of years. Murthy pointed out also very succinctly early in his slides about the cost factor of not doing the work, the knock-on effect of the investment, either in someone's bought unit or in a commercial terms in the use of that property in office space and things like that, and tenancies. So this brings an awful lot of responsibility onto a management company to approach proactive maintenance in such a manner that there's no surprises per se. This is why we put reserve funds in place, and with scheduling reserve funds and sinking funds, maintenance plans can also not just be an operational annual aspect or 2 or 3 years. It can be for many years to come, to make sure that cost line and expenditure for people is kept stable. So if we use that as an objective for us, when we're looking at walking into basements and looking at some of these problems that have been pointed out, effervescence and small leaks, maybe little spalling or damaged paintwork, our due diligence is that there seems to be a problem, but knowing what that problem is and how risky it is, we don't really know, because we're not the technical expertise. And it's at that point, I suppose, our expertise is knowing how to approach these problems in the most optimal and economic way forward. The issue in Dubai is, well, it's not just Dubai, but predominantly here with our issue is that the buildings all have basements. They usually do have some form of leak or deterioration, paintwork, etc. And because it's so prevalent in most basements, because of the groundwater and the salinity, it becomes almost a norm. And the manager of a building may expect the lifetime to be 50 years or more. So of course, why would this 10 years in be a problem? And is that going to be, why can't we just fix it ourselves? Let's use the maintenance company just to put a lick of paint over it. It's very cost effective. We can keep doing that all the time. But you do have this cost increase over time, that if you don't see things early, then you may have much bigger problems or problems earlier and costs earlier, so that our curve of expenditure peaks earlier, and people then are surprised that the costs have mounted through the service charges, or the reserve fund is diminished because the spend is going on areas that they weren't expecting to do. So this is our problem, and our task to resolve these things. And I admit I'm not an expert in concrete structures or in the remedy of them, but I understand that there is a degradation of it, and that we need to get an expert in to really tell us what that's like, and then to kind of bring that together to understand what the best foot forward is of that. So bringing back to what Murthy was saying in terms of commercial losses, are going to be very impactful on the building and us. The disruption to all of the occupants of the building is also a major concern. I wanted to touch on also warranties, and that you can rely on the contractors or the main contractors or the providers of the warranty as a subcontractor. But if you're in a position of some huge expenses later on, I think it's probably worthwhile getting independent inspection that acts for you as either the manager for the client or on behalf of the client themselves, so that you're in a position to be able to take decisions from a third party as well, rather than rely on the cost saving, which may not be the case from a warranty. At least someone can see that the warranty is being upheld properly and the right works are being done, which comes down to track record and the credibility of the companies being used. So just to kind of bring that all together, I think I saw a glimpse of a question that came out from somebody just earlier, that was that what is the most economic approach to the resolution of leaks in basements? And it's not what the remedy is and the actual technical repair. It's how you approach it is where the economy comes in. It's finding it early. It's getting it inspected by a credible and technical expertise that can then advise you how to move forward with that. And it's bringing a team together that have a cultural likeness to move forward to resolve the issue at the most optimal way of doing that. I've kind of touched on what we're going to be talking about Wednesday, so I'll stop there. And I hope that I've then brought a circle really to what Murdi was saying, and the importance of acting early with expertise, and to save those costs that are going to mount by ×5 if you don't. I'll hand back over to Karim now, and thank you very much all for listening.
So thank you, Nick and Murti, for sharing your experiences and insightful information. So before we actually get into the Q&A, I just wanted to remind everybody to fill out the short survey that is going to be popping out once you actually close the Zoom session. And one more thing, I just wanted to also remind you guys, if you haven't registered for tomorrow's and the day after tomorrow's webinars, to register. And now I'll get to the Q&A. Nick, I'll start with you. Just a quick question that seems interesting, or from property management perspective. So when is the right time to actually seek out the assistance of a durability engineer or a specialty concrete consultant? Is it when you start to observe the deteriorations on the structure, or is it prior to that, or when exactly do you suggest is the best time to actually do that step?
Well, I think that brings me on to the early timing of the aspect. I mean, the quicker that you can pinpoint what's going wrong, the more costs you will save ongoing, so that the service charge expenditure can be reduced over time. You don't know what you don't know, and the cost of an inspection, when it's effervescence, or that it seems that it's not an important issue and that can be resolved by the facility management team or your own team on site. Yes, that's probably the case there and then, but there's the risk there that what is actually being done to remedy could be a much more cost-effective plan for a longer term. Rather than just paint it, there could be something else that an expert would say, well, why don't we do this also? But it's only a little bit more cost, but what it's going to do is prolong that problem, not problem, remedy the problem for longer, which you can then, from dealing with a consultant and an inspection, you can then weigh up whether it is you have the budget for it, or it seems to make sense to you. If you don't do that, you don't have that opportunity. So that's the time, and is to actually look at earliest as possible, because it'll just be a small visual look rather than an invasive concrete repair kind of aspect.
Yeah. So, Mr. Murthy, you also, one of the questions that is interesting is, it asks, based on your experience, what distinguishes a good, I'd say, investigation or durability report than another one? So what are some of the major things that either you as a company or you as an expert in the field look at or think is very intrusive and needs to be there, or will distinguish a report from the other?
Karam, I don't know who asked for us that. Actually, I have explained it in my previous slides. What's the difference made by the consultant versus another consultant? I have shown 2 live examples of consultant. I said I use it. I say that probably because of insufficient knowledge. Some people are using the wrong codes in order to justify the service life of the structure or remaining service life of the structure. And how do you distinguish? How do you go to the guy? How do you know, who is the right guy? I think it's mostly your own homework, but I want to point out here, I think there is one question from the engineer's office where he was asking, hey, how do I distinguish a good consultant from not so good one? I wouldn't use the word bad one. There was a rating or exercise that was being initiated by one agency from UK, which came here, and they tried to rate the consultants, durability consultants, restoration consultants, and contractors as well, according to their track record, knowledge, the personnel. But unfortunately, that did not take off in this country. But if we have something like that, similar to what we have in UK, it brings a big relief to the owners. At least they can go and say, if you are a registered one from that entity, then yes, you have a certain pre-qualification that they could be considered. Now, it's also I'm going to be looking at it very seriously after I see this question from the engineer's office. I know whom to contact and try to revive this, because I honestly believe the good consultants must be certified and distinguished from the not so good ones.
Okay, another question says that one of the biggest challenges for clients whenever there's an issue with their basements or their assets or structures is to try to quantify the budget during the assessment phase. Now, what is your advice on how we can better help the clients, or how the clients can actually have a better advice on defining these budgets before the repairs are actually taking place?
Okay, there are 2 ways of doing it. As I always say, the very basic one is employ a good consultant, because a good consultant is able to quantify your problems as it appears today. Right. Okay. Now, once that happens, if you can speed up the process of getting it done, let's say within 6 months or so, then normally that consultant makes a certain provision. For example, you can say, okay, all right, I'm going to do 20% more than what I see today by the time the repair contract is going to be awarded. It will work. But what happens is that you have certain procedures in the government, and by the time it comes out for tender, it's 3 years. And then you have the problem of having areas being doubled even. In such a case, then you go back and fight and say, okay, all right, the contractors, what they do, they say they quantify. They cannot give a lump sum because they don't know, because probably your bill of quantity that you give today is not going to match for tomorrow. So as I said, there are 2 ways of doing it. One, speed up the process of doing the mitigation, number 1. Number 2, you can still do a very accurate fairly accurate, I wouldn't say very accurate, a fairly accurate calculation using Stadium, where Stadium can tell you 2 years down the line, your repair can be so much, your cost can be so much. With the Stadium, we even calculate what shall be the repair cost 10 years down the line. So,
okay, since you also mentioned the Stadium program, there's a question that asks, so the service analysis that is being done using the Stadium program, it takes into consideration the environmental parameters of the structure, right? Or the area of the structure.
That's correct.
Can you please just elaborate just very briefly on how, for example, modeling a structure here in the Gulf region is different than modeling another one in North America, for example? Like how will you be able to capture the environmental parameters?
The environmental parameters are your relative humidity, temperature variance, as I mentioned, the salinity in your water, etc., even your wind velocity. Everything plays a role when you are going to be doing this modeling and calculations. We have run many calculations for the Gulf region, even though that we do all the calculations back in Canada, but we have done many, we have extracted the cost, but we have used the database that we have for all over the country is, for example, we know exactly what are the properties of the aggregate that are available in Ras Al Khaimah. We have that kind of database. So we can use the database not only of the material properties that are available here, sometimes if need to be, we even do the actual casting and run the calculations. But we do it for very, very major work, such as when you are going to build a port, for example. There it justifies the cost, but not for a normal commercial building. But where we have the database for all the environmental conditions that are existing, whether it is in Abu Dhabi or in Dubai, both the groundwater salinity and the temperature relative humidity, etc. We have the database and we can use it in order to model it.
Okay, so one more question that is tied maybe to the maintenance and the topic that we're talking about today is somebody's asking about what is the difference between the design life and the service life?
That's why in the slide that I showed, the design service life. Actually, the design life is not just a design life, design service life. The design life is the service life or the designer, he is designing a building to get you a service of 50 years. It's actually design service life. There is no difference. But you can ask me a question, what's the difference between the design life and the actual service life? That's
I think that was the question. So what is the difference? And I think it's tied to some of the issues that you talked about, right?
Yes. The design life is, for example, as I told you, according to the code recommendations, we design it for 50 years. But the design service life would be much less than the 50 years. Because at 10 years, you see the problem that you should see normally at 30 years or 40 years here. Because of many reasons, which I have highlighted. You have the system failures, and you have construction qualities, and you have other environmental conditions which are very, very aggressive. And here you have to be more careful than anywhere else. Yeah. Once I was in Germany and I was asking the guy who was building a basement, I asked him what kind of waterproofing you use. He said none. We don't use any waterproofing. But can we say this here? No, we cannot, because we cannot expose the concrete structures here without any waterproofing.
True. So one more question asked about, is it true that corrosion can occur even under complete submersion? Some labs, some laboratory tests have shown that molecularly bond oxygen can cause corrosion. What are your thoughts on that?
Yeah, whoever has asked is a very interesting question. We were also surprised when we realized that in the first time in the port of Rotterdam, where we have been acting, we run the stadium for 8 years. I mean, we have a contract with Port of Rotterdam. There we found in a fully submerged condition of a pipe where the oxygen is not supposed to be there and your corrosion shall not happen. We were very, very surprised. We have seen the corrosion that's happening. The corrosion has happened because of what you have just explained, but it's not as huge as what it would be otherwise. Yes, there is corrosion, but not as much.
Okay, another question asks about a repair technique, and I just want to mention to everybody that I think that we're going to be discussing the repair techniques in tomorrow's presentation. However, the question asked is, in case of leakages in a basement from the outside, the positive side, so the existing waterproofing membrane has failed for some reason, what is the most optimized solution, or could cementitious grouts be used? Injection of cementitious grouts are enough, or is there any other methods that you think could also work?
I would not advise an injection of the cementitious grout, because cementitious grout, you see, a crack has happened. Because of the crack, you have the water leakage. It is a possibility that the crack can keep moving. That being the case, by injecting a cementitious grout being a rigid one, it might not serve the purpose. So I would always recommend an elastomeric resin injection.
Okay, another question, and again, I just want to point out that tomorrow I think we're going to be addressing the repairs, and tomorrow we also have Mr. Bill Hutton, who's a CP specialist. But the question says, Muti, is that can you actually provide a CP system for 50% of the structure, knowing that it will create some different levels of polarizations areas that will create a malfunctioning of the CP system and might create a massive interface currents?
The answer is yes, but it will be addressed by the specialist tomorrow, Mr. Bill Hutton.
Yeah. So I just wanted to thank everyone again. Nick, thank you so much. I know that we're going to be seeing you again on Wednesday. Mr. Murthy, thank you. I want to appreciate everybody's time and hope that we were able to bring or share some of the experiences that we have with you all. And I truly hope to see everyone on tomorrow's and day after tomorrow's presentations. Thanks again. Have a good day. And don't hesitate to reach out to any of us if you have any questions or for the free basement inspections as well. Thank you.
Thank you, Karam, and thank you everybody for watching. Thank you.
Thanks all.